Good morning to one and all. So I am going to discuss about the vector analysis in the electromagnetic field. So electromagnetic is a branch of physics or electrical engineering which is used to study the electric and magnetic phenomena. The electric and magnetic field are closely related to each other. You have to see what is the field. If you have considered a magnet, so it has own effect in the region surrounding it. The effect can be experienced by placing another magnet near the first magnet. Such effect can be defined by the particular physical function. In the region surrounding the magnet, there exists a particular value of physical function at every point, describing the effect of magnet. So the field can be defined as the region in which at each point there exists a corresponding value of some physical function. Thus, the field is a function that specifies a quantity everywhere in the region or space. If at each point in the region or space there is a corresponding value of some physical function, then the region is called as a field. If the field produced due to magnetic effects, that the particular field is called as a magnetic field. So there are two types of electric charges. First one is the positive charge and negative charge. Such an electric charge produces a field around it which is called as an electric field. Moving charge produces a current and current carrying conductor produces a magnetic field. In such a case, electric and magnetic fields are related to each other. Such a field is called as an electromagnetic field. The comprehensive study of characteristics of electric and magnetic combined field is the engineering electromagnetics. Such fields may be time varying or time independent. It's seen that a distribution of quantity of space is defined by the field. Hence, the quantity of the field three-dimensional representation plays an important role. Such three-dimensional representation can be made easy to use the vector analysis. The problems involving various mathematical operations related to the field distributed in the dimensional space can be conventionally handled with the help of the vector analysis. A complete pictorial representation and a clear understanding of the field and laws governing such fields, if possible with the help of the vector analysis. Thus, a good knowledge of vector analysis is essential prerequisite for understanding engineering electromagnetics. The vector analysis is a mathematical tool which is the electromagnetic concept. It can be most conventionally expressed. So next one is the scalar and vector. So various quantities involved in the study of engineering electromagnetics, it can be classified as scalar and vector. So scalar is a quantity whose value may be represented by a single real number which may be positive or negative. The direction is not all required in describing the scalar. The scalar is a quantity which is represented by its magnitude. The various examples of scalar quantities are temperature, mass, volume, density, speed, electric charge, etc. So the next one is the vector. So the vector quantity is both magnitude and specific direction in the space is called as a vector. In electromagnetics, vector is defined in 2 and 3 dimensional spaces are required, but the vectors may be defined in n dimensional space. A vector is a quantity which is characterized by both magnitude and directions. The various examples of vector quantities are force, velocity, displacement, electric field intensity, magnetic field intensity, acceleration, etc. So next one is the scalar field. A field is a region in which a particular physical function has a value at each and every point in that region. So the distribution of scalar quantity with a definite position is called a scalar field. For example, temperature of the atmosphere, it has a definite value the atmosphere but no need to direction to specify, hence it is called a scalar field. The height of the surface of each and above sea level is scalar field. For other example, if the scalar field or sound intensity in auditorium, light intensity in a room, atmospheric pressure in a given region, etc. So next one is the vector field. If a quantity which is specified in a region to define a field in a vector form is corresponding to the field is called as a vector field. For example, gravitational force on a mass in a space is a vector field. The force has a value at various points in a space or always has a specific direction. The other examples of vector field are the velocity of particles in a moving fluid, wind velocity of atmosphere, the voltage gradient in a cable, displacement of flying bird in a space, magnetic field existing from north to south field. So these are the very basic fundamental concept we have to discuss with that engineering electromagnetics, that is the basic fundamental, then vector and scalar field. Thank you.